Welcome back. The topic is limits at infinity. We shall evaluate two examples. One is the expression in the form of rational function. Second one is a simple algebraic expression. Friends, please see the complete video. If you are new here, please subscribe the channel. Our examples are respectively this one and that one. Okay, how to evaluate this type of limits? First of all, we shall learn the algorithm. See that first one is in the form of fx by gx. This is a rational expression, so there is no problem. But the second one is a simple algebraic expression, so we have to make it in the form of fx by gx. Okay. Next is number 2. We have to observe if k is the highest power of x in numerator and denominator both, then divide each term in the numerator and denominator by x to the power k. We have to divide both numerator and denominator by x to the power k. Okay. Third step is, after some calculation, we have to use this one. Limit x tends to infinity, c upon x to the power n is equal to 0. Another one is a limit x tends to positive infinity of c, that is the constant is equal to c, where n is greater than 0. We shall use this algorithm and we can evaluate this type of limits. Okay, first of all we shall take the first example. Our first example is this one. Okay, in this example, what shall we do? First of all, we shall observe that what is the maximum power of x. Here, in both numerator and denominator, we find that the maximum power of x is 2. So we shall divide both numerator and denominator by x square. Limit x tends to infinity, ax square plus bx plus c divided by x square, dx square plus ex plus f divided by x square. So that we are getting limit x tends to infinity, ax square by x square means a. Next one is bx by x square, that means b by x plus c by x square, and the denominator will be now d plus e by x plus f by x square. So friends, now when we use the limiting case, that is x tends to infinity, where x is a large quantity, then b by x square will tend to 0, c by x square will tend to 0, like this e by x and f by x square will tend to 0. So in the limiting case, we shall have a plus 0 divided by d plus 0 plus 0, so that we are getting a by d. So a by d is the limiting value of the function, rational function ax square plus bx plus c divided by dx square plus ex plus f when x is tending to positive infinity. Okay, this is the limiting value. Now we shall take the second example. Our second example is limit x tends to infinity, root over x square plus x plus 1 minus root over x square plus 1. So according to the algorithm, we have to make it in the form of fx by gx. So this is limit x tends to infinity, root over x square plus x plus 1 minus root over x square plus 1, multiply this by the conjugate root over x square plus x plus 1 plus root over x square plus 1. Also we have to divide this by this quantity, that means root over x square plus x plus 1 plus root over x square plus 1. Okay, so now in the numerator we find that this is a minus b into a plus b, means the formula is a square minus b square. Again I write this one, a minus b into a plus b. So the formula is a square minus b square. we shall use this formula. Okay. So the numerator becomes limit x tends to infinity. The denominator is as usual x root over x square plus x plus 1 plus root over x square plus 1. Okay. And the numerator is now x square plus x plus 1 minus root x square plus 1 whole square means only root x square plus 1. Before that there is a minus sign for this minus x square minus 1. So we can cancel x square and 1, so that we are getting limit x tends to positive infinity x divided by root over x square plus x plus 1 plus root over x square plus 1. Friends, now we have to divide both numerator and denominator by x, because the maximum power of x in both numerator and denominator is 1. Here you see that the power of x is 1. Also in the denominator also you will find that the power of x is 1, because you are looking here there is x square, but after root you will get linear form. So limit x tends to infinity, numerator now will be 1 only, and the denominator is like this, root over x square plus x plus 1 plus root over x square plus 1 divided by x. So that this is equal to limit x tends to infinity 1 divided by root over x square plus x plus 1 divided by x square plus root over x square plus 1 divided by x square. So break this one, limit x tends to infinity 1 divided by root over 1 plus 1 by x plus 1 by x square plus root over 1 plus 1 by x square. So in the limiting case, when x is tending to 0, then 1 by x square, or here also 1 by x square are tending to 0. So in the limiting case, we shall find 1 divided by root over 1 plus 0 plus 0 plus root over 1 plus 0. So getting 1 divided by root 1 is equal to 1, root 1 is equal to 1. So this is 1 by 2. So the limiting value of the given function, our function was root over x square plus x plus 1 minus root over x square plus 1. Its limit is half. Its limit is half. We have got it. This is the value. This is the limiting value when x is tending to infinity. Okay. Thank you. Have a nice day.